Every human society ever observed cooks. Not every food, obviously, and not every bite, but every culture, from people living on Arctic ice to people foraging under rainforest trees to someone blinking sadly at a microwave at midnight. A lion has never looked at a gazelle and decided it needed rosemary. A monkey doesn't fry fruit. A bird has never assembled a meal. So the question that sounds stupid is actually rather serious. Why do humans cook? Because cooking isn't just cuisine, and it probably didn't begin because some prehistoric person wanted dinner to feel more complete. It began, most likely, because fire accidentally revealed a cheat code. Food near fire became softer. Food near fire smelled better. And, rather inconveniently for every raw food purist on the internet, food near fire often gave the body more usable energy. That last part is the one that matters. Because humans are not built like excellent raw food machines. We have small teeth compared with other apes, relatively weak chewing equipment, and guts that seem rather committed to high quality food, which is a polite biological way of saying we don't handle endless bark and raw tubers with much dignity. Richard Wrangham and Nancy Lou Conklin Britton pointed out that no known human foraging population has been recorded living completely without cooking. Again, not cooking everything, just never living without it. And when modern people voluntarily try long term raw food diets, the results are not exactly an advertisement for returning to nature. In one German survey of 513 adults, men lost nearly 10 kilograms on average, women lost about 12, and a substantial share became underweight, with about 30% of women under 45 reporting partial or complete loss of menstruation, which is a fairly blunt reminder that nature is not always whispering wellness advice. Quick pause, because videos like this take hours of research before a script even starts, which in this case means archaeology papers, anthropology arguments, and actual studies where scientists fed mice cooked steak, because academia is occasionally much funnier than it intends to be. So if you're enjoying this, please like the video, share it with someone who overthinks dinner, and subscribe, if only to encourage more highly specific historical nonsense. And comment below if there's some everyday human behavior you want looked at next, because apparently even boiling potatoes has a million-year backstory. Okay, back to the first dinner party. The earliest version probably wasn't dinner in any recognizable sense. There may have been no plan, no recipe, no charming communal feeling, just a dry landscape after fire had passed through, and some animal or underground root that had been accidentally roasted. A hungry hominin picks it up, bites into it, and discovers, with no biochemistry whatsoever, that this is considerably easier than gnawing the raw version like a furious beaver. Before cooking, there was already food processing. Early humans and their relatives were cutting meat, cracking bones, pounding plants, and generally outsourcing some of the work their teeth were not especially thrilled to do. The oldest widely accepted stone tools are around 2.6 million years old, which means knives and hammers came before anyone can confidently point to a kitchen. Then, around 1.9 to 1.8 million years ago, Homo erectus appears, with a bigger body, a larger brain, and smaller teeth and jaws than earlier ancestors. Wrangham's bold version of the story is that this is when cooking had already become important, because softer, energy-rich food could help explain a body that suddenly seems less interested in chewing all day. The problem is that fire is an obnoxiously fragile thing to prove. Ash blows away, burned sediment can come from wildfires, and a black patch in the ground doesn't automatically mean someone was thoughtfully roasting dinner. At Kubi Fora in Kenya, there are possible fire traces around 1.5 million years old. But possible is doing a lot of work there. The stronger early case comes from Wonderwork Cave in South Africa, where researchers found burned bone and ashed plant remains deep inside the cave, in deposits about 1 million years old. That depth matters, because a natural grass fire does not usually stroll politely into the back of a cave. Still, even that doesn't give us a menu. The oldest evidence that looks very much like actual cooking is much more oddly specific. It comes from Gesher Benot Ya'aqov in Israel, near the old Lake Hula landscape, where hominins were catching large freshwater fish. And the clue wasn't a beautiful charred fillet, because archaeology rarely gives anyone the courtesy of being obvious. The clue was ancient fish teeth, about 780,000 years old. Researchers found more than 40,000 fish remains at the site, and in key layers, the remains were dominated by pharyngeal teeth, the grinding teeth fish carry deeper in the throat, which is, frankly, a sentence no one expects to need. Those teeth were found near phantom hearths, clusters of burned flint too subtle to look like a campfire, but suggestive enough to make archaeologists lean forward. X-ray analysis suggested the teeth had been heated below 500 degrees Celsius, which points more toward controlled cooking than fish casually obliterated in open flames. So the oldest cooked dinner we can talk about with real confidence may be carp teeth, not exactly rustic fine dining. The same landscape also produced evidence for a broad plant diet, including seeds, fruits, nuts, and underground storage organs from 55 edible plant taxa, which means these people weren't just meat enthusiasts with worse lighting. They were living in a complicated food world, and fire made more of that world edible. Mechanically, cooking is almost embarrassingly effective. Heat denatures proteins, softens connective tissue, weakens plant cell walls, and gelatinizes starch, which is why cooked potatoes behave like food and raw potatoes behave like a dare. In plain terms, cooking starts digestion before food enters your body. It's an external stomach, a slightly rude phrase, but genuinely useful. Calories printed on a label are not the same as calories your body actually gets. If the food is raw and structurally defended, some energy passes through you, and some costs more effort to extract. Rachel Carmody and colleagues tested this rather directly in mice, feeding them sweet potatoes or lean beef, served raw, cooked, whole, or pounded. The mice gained more energy from cooked meat, not simply because they ate more or became tiny lazy kings, but because cooking changed what their bodies could use. The mice also preferred cooked foods in choice tests, choosing cooked options on the first bite in 14 of 16 cases, which is not human evolution by itself, obviously, but it does make the whole discovery of roasted food feel less like genius and more like an animal having a very good day. Cooking also kills many parasites and bacteria in meat and fish, and it can reduce toxins or irritants in certain plants. Ancient humans did not need germ theory for that to matter. Groups that cooked risky foods more often would simply get sick less often, which is the kind of evolutionary advantage that doesn't require anyone to understand why it's happening. And then there's time. Other primates spend huge portions of the day feeding because leaves and raw plant matter demand patience, jaws, and a lifestyle with very few hobbies. Humans spend only about 4.7% of daily activity time feeding, far less than expected for a primate our size. Cooking gave time back, not just calories, time. That matters because the human brain is absurdly expensive. In adults, it makes up only about 2% of body mass, but uses roughly 20% of resting energy. So if you're a relatively small-bodied ape trying to run a large brain, you need a way to pay the bill. The expensive tissue hypothesis argues that energy saved in one place, like the gut, could help support energy spent somewhere else, like the brain. Cooking fits into that bargain rather neatly, maybe too neatly for everyone's comfort. Because if cooked food helped make bigger brains and smaller guts possible, then cooking didn't just make food easier for humans, it may have made humans dependent on easier food. That's the slightly unsettling version. Fire wasn't just a tool we used, it was a tool that changed the kind of animal using it. The mental pieces for cooking may not even be uniquely human. Chimpanzees don't cook in the wild, which is probably for the best, given their already confident attitude toward chaos. But experiments show they often prefer cooked food, and in one set of studies, they could wait for food to be transformed, give up raw food to have it cooked, and even carry raw food to a cooking-like device. So the missing ingredient may not have been desire,
It may have been reliable control of fire. Once fire was controlled, it also changed the shape of the day. Darkness no longer ended everything. People could gather after sunset, eat food that had to be protected and shared, teach children what was safe, argue about whatever prehistoric people argued about, which was probably not that different from now, and sit in one place long enough for a hearth to become a center. At Qasem Cave in Israel, for example, archaeologists found evidence of a repeatedly used central hearth around 300,000 years ago. Not a random flame, a place.
And among the Hadza of Tanzania today, fire has many jobs, from cooking meat and roasting tubers, to making torches for honey collection, to straightening arrows. Fire is not one invention, it's a platform, and cooking may have been the application that got inside our bodies. The big disagreement, still, is timing. Did cooking become central early enough to shape Homo erectus almost 1.8 million years ago? Or did habitual cooking only become common much later, after hearth evidence becomes clearer around 400,000 to 300,000 years ago? The fossils seem to whisper early. The ash record keeps asking everyone to prove it. And that tension is probably the honest answer. Cooking didn't begin as a grand human project. It was probably an accident, repeated because it worked, then a habit, kept because it fed people better, then a dependency, hidden so deeply in the body that it stopped looking like culture at all. The unnerving part is that fire didn't just soften meat and open plants. It moved part of digestion outside the body, and once an ape learns to carry part of its stomach in the world, very quietly, starts redesigning the ape.